Okay, so let's start the course then. I did the introduction, told you what's going to be in it. What we are doing here is just start with the very basics of which are the oceans. We all know that the oceans cover more than 70% of the Earth's surface. Then why is it called Earth, not Oceanus or something? You have to remember that the name came a very long time ago when people didn't even know that the oceans were so vast and the Earth was a sphere and there was anything beyond where people were recording things like, let's say, Greece or so. So the names mostly originate from there. And we will go through and see how the historically new oceans were found, how colonization of various places happened, and so on. As to the water itself on Earth, we have to remember that it is still being discussed where the water came from. It's pretty clear that there were oceans on Earth from the very beginning, but considering the distance from the sun, we have to imagine how Earth could have retained water. Where could it have come from? The outer planets far away from the sun have frozen water, for example, ice on various planets and their moons, Jupiter, Saturn, Europa, Enceladus, and so on. So the latest theory would say that during the accretion, there was a lot of chondrites, the so-called chondrites, which are meteorites that are formed early on, that are not modified by any of the processes along the way. Once in a while, they fall onto Earth, or they have been on Earth fallen from before, that you can look at them and say where the origin of water would have happened. So it's pretty clear that during the formation of the planet itself from the nebular dust, the so-called accretion process probably also brought us water. With that basic background, which we'll come back to a little bit more later on, we'll just look at the oceans. Technically, they are all connected, so we should call it just the world ocean, which most of the time we do. But we also always look at regional oceans for various processes at various time scales, like the monsoon, the El Nino, and so on. So we divided the world ocean into the Pacific Ocean, which occupies more than 50% of the surface area of the oceans. Atlantic Ocean is the next one, Indian Ocean, and then there is the Arctic Ocean at one pole and the Antarctic Ocean at the other pole. Very briefly, the name Arctic comes from its location. It's under the constellation, the Bear, which is Arctos in one of the Scandinavian languages, I think. And that's where the Arctic comes from. Antarctic is at the other end of the ocean. So Southern Ocean or Antarctic Ocean is at the other end. The size of the ocean and the depths, obviously, land has about 30% or less of the Earth's surface area. And in terms of relative size, we have Arctic, which is 3.4%, Indian Ocean is 20.5%, Atlantic is 26%, Pacific, as I said, is just over 50%. Average depth of the ocean, the Pacific is a little bit deeper than the Atlantic, which is almost the same as the Indian Ocean, but the Arctic is fairly shallow compared to these other oceans. The interesting thing is that the Mount Everest, which is the highest point on Earth at more than 29,000 feet or about 8,850 meters. It keeps growing every year, of course, because the Indian continent is moving into Asia and raising the Himalayas. But the interesting thing is that the ocean has many more much taller mountains. For example, the deepest trench in the ocean is in the Pacific, the so-called Mariana Trench, which is more than 11 kilometers deep. That's much deeper than the height of the Mount Everest. So we hear a lot that the ocean has not been as explored as even the moon or maybe even Venus, but this is changing. There are a lot of autonomous vehicles that are exploring the bottom of the Earth. Plus, I'm sure many of the navies around the world have a lot of data that's not made public. So in the next module, we will look at specific oceans and try to understand some of their specific characteristics. So I will stop this module here, and we will come back to next module very